Hi everyone, welcome once again to another tutorial session in machine learning. In today's video, I am going to show you how you can compare and visualize the performance of machine learning classifiers using Heatmaps. This is the first episode in the series and I am going to upload the second episode once that is also complete. For this tutorial, we are going to compare the performance of 8 classifiers. They are the ones that have been listed here: Adder Boost, Extra Trees, K-nearest neighbor, Logistic Regression, Naive Bayes, Random Forest, Support Vector Machines, and XGBoost. There are lots of classifiers available, but I'm using this one because they are convenient for me to use for this particular tutorial. And so if you are going to use a classifier for your work, you need to read about it and look at what works best for you. Okay, so each of these classifiers have their strengths and weaknesses, so it's advisable to read about them and then decide whether they will work for you or not. For the performance, we are going to use these metrics: accuracy, F1 score, precision, recall, Collins kappa statistic, and Matthews correlation coefficient. Again, there are dozens of metrics available, and so you need to look at what works best for you. So take note of that. And so by the end of this tutorial, you would have been able to generate this heat map that is being shown right now. And I am going to interpret this heat map at the end of this practical session. So let's proceed. Now for this tutorial, we are using Python. And so if you have Python on your PC, then you need to make sure you have these libraries also installed. If you don't have Python, don't worry. We are going to use an online platform to run the code. So let's do that. The notebook for this tutorial is available on my machine learning GitHub repo, which is here. And I'll leave the link to this page in the description box. So take note of that. So just go to notebooks. And when you are in that particular directory, go to the evaluation folder or directory. So just click it and then you have some notebooks here. Okay, so the notebook for this particular tutorial is this one here. The one with this name, Compare Classifiers Using Heatmaps, episode 1. So let's go back to our Python interface here. Now, if you don't have Python installed, let me show you how you can run this particular notebook using your internet browser. So first of all, you need to take note of the link for my main GitHub repo, the machine learning repo, of course. Again, the link is in the description box. So just get that link and then go to Google Colab. I'll leave the link to the Google Colab homepage also in the description box. So when you are on the Google Colab platform, just come to GitHub, this particular side here. Click GitHub, and then here you can paste that link, the link to the machine learning repo. So once you have pasted this link, just search using this particular button here. So just click search, and then when you click the search button, you have a number of notebooks appearing. So search for the one which is notebook/evaluation, and then the name of the notebook we are using for this tutorial, which is Compare Classifiers Using Heatmaps. So this particular notebook here. So once you have it, just click it, and then you have access to the notebook. So just take note of that. Sometimes when you visit the Google Colab platform, you may click outside this window, and if you do, you will have this appearing. You can bring that window back by going to File and then clicking on Open Notebook. And then you can go to GitHub, paste your link, and then search for the notebook that you want. So this is how we open Python notebooks directly from GitHub using Google Colab. Now let's get back to our notebook. I'll switch to this particular one here. Once you have your notebook open, the first thing you have to do is to import your libraries. And again, let me say that these are the required Python libraries you need to install if you want to run the notebook locally on your PC. So NumPy, Pandas are used for handling the data. Matplotlib, Seaborn are used for visualization. Scikit-learn is used for preprocessing and then classification. And then XGBoost is also a separate library that I have to install in order for me to get access to the XGBoost classifier. So that is how it is. Now let's proceed. So I have the cell here that has the codes to import the libraries. So there are comments there to help you know what each of these groups of codes are doing. So just read them and then get started. So I'll run this cell and then I'll proceed. The next thing I have to do is to read the data. So here I'm going to use Pandas to read the data. The data is available on my GitHub repo, this particular file here. And this data was obtained from this paper. In this paper, they use machine learning approaches to classify different malaria outcomes based on hematological parameters. So it is these hematological parameters that I have stored here. So take note of that. So I have also made a separate tutorial where I try to reproduce this paper using Python. So if you're interested, you can watch that video. The link is in the description box. So take note of that. Now let's proceed. So let's go back to our notebook. You can also see that here I am using the URL, the file URL. This is because Pandas can read files on remote servers. So you don't need to have the file on your PC. If you have the link to that file, you can still supply it to Pandas and it will read it. So that is what I have done here. So I'll read the file now. Okay, so after reading, I just want to check the sample size. So I say data frame.shape just to get the number of samples. So here are the number of samples. And then these are the columns or the features. So we have 2207 rows and then 34 columns. So the rows here refer to the number of samples. So take note of that. Now we are going to do a bit of exploration and cleaning. It's important to always explore your data so that you can understand the data, and then the information you get can help you to determine the methods to use for the downstream analysis. In the course of exploring, you also get to clean your data. So I'll be brief because the focus of this tutorial is to generate the heat map. So there are a number of things that I will not discuss here. So here, I want to get a subset of the data. So this command will help me do that. And then I'm also going to remove all rows with missing values. It's always important to look out for missing values and then deal with it, because this particular issue of missing values can impact negatively on your outcome. So always deal with it. So I'm going to drop all rows with missing values. And then I also want to get the class or the outcome. So I'll just run this. So here we are dealing with 3 different malaria cases or classes. So I have 3 classes here. So this is a multi-class problem. I will now proceed to do some preprocessing. I am going to separate the class from the features. So I'll use this command to do that. And then I am going to encode the labels. It's important to encode the labels because scikit-learn requires that your labels or the class you encode with values. So here I'm going to encode with values between 0 and then n classes -1. So that's what I'm going to do here. So we have 0, 1, and 2. So 0 for one class, 1 for another class, and then 2 for another class. So this command will help me do that. So I'll run this. Okay, so I'm using label encoder here. So let's check the encoded values. So I'll say, let me just check here. So I have labels. Let's get a summary and then classes. Okay, so it is this particular one here that we are going to use. The labels here is just telling us the original data, what it was, the contents. So that's what you need to know. So this is the summary. So if you want everything, you can just use Y encoded to give you everything. So you can run that to get it. So take note of that. So let's proceed. So the next thing we have to do is to normalize the data. It's important to always normalize. It helps to avoid bias. So here I will scale the data between 0 and 1. That is what I will do here. After normalization, I proceed to split the data into train and then test subsets. So I'll run this command to do that. Let me check. I just want to confirm. So I will check the number of samples in the training and test set. So I'll say xtrain. I'm starting with the training set. So xtrain.shape. I'll also do the same for the test subset. So it's here. Okay, so I have 432 samples in the test set and then 1,724 samples in the training subsets. In this tutorial, I am using 80% of the data for training and then 20% for testing. So take note of that. It's now time to train and then evaluate the models. So to do that, I have two functions here. One function is used to evaluate the models. That is this one here. And then the other function, which is here, is used to fit the models to the training data. So I have them here. Functions allow us to reuse codes. So take note of that. Now let me run this particular cell to create this function here. And I also run this cell to create this other function, the fit data function. Let me explain a couple of things in this function here, especially for beginners. I'll highlight the important parts. So these are the models. Okay, so here I fit the models to the training data. Now let me scroll down. There is an empty list here. So this empty list here is used to store the scores for all the classifiers. So after calling the function to evaluate the models or classifiers, the scores that are returned are stored here. So this helps us to aggregate all the scores. And there's also a performance metrics list here. So this has the names of the metrics. And there's an indices here. So this indices here is used to store names that are assigned to the models or classifiers. So there's also a dictionary here. So this dictionary here stores the models, and then because dictionaries comprise of a key value, the key here becomes the name that I give to the models, and then the values here are the models themselves, the objects, the ones here, like this one here. So that is what I have here. So once I have the dictionary, I just use a for loop to iterate, and then for each object, for each key value, which is the name and then the model, I just call the evaluate function here. I supply it with the model itself, and then I get the scores. Okay, and then the scores here, I just put it here. That is what this is for. And then the name of the model is also placed in this particular list here, the indices. Okay, and then once I have that done and I have everything that I need, I finally generate a data frame using the information. So I have the performance list. That is the list that has all the scores. That's the data. And then the columns here will refer to the metrics, these ones here. And then the indices becomes the names of the models. So take note of that. So it's just a way to organize the results, okay, into a format that we can easily manipulate and also export or save. So that is what this is for. So I'll run this cell. And finally, I'll generate all the scores using this line here. So this will call the function to fit the models. And then in that function, the evaluate function is also called to evaluate the model. So that's it. So I'll run this cell. Perfect. So I now have that particular result. So now let's check the results. What we have here is a Pandas data frame. But if you are not sure, you can use this command to check. You can say type results. This will display the data type. So we are dealing with a Pandas data frame. Let's display the data frame itself. So we say results. Perfect. So now we have our table being displayed for us nicely. It now becomes easy to interpret the outcomes or the results, okay, because we have organized everything very well. I'll use this time to also introduce some of you, my viewers, to how we can make queries in a Pandas data frame. So let's just say we want a subset of this table, okay, a subset which has models with F1 scores greater or equals to 0.81. We can do that. So we can say results. We indicate our square brackets and then we type results again. That is the data frame. And then we indicate our column of interest, which is F1 score. And we say greater or equals to 0.81. And we run this command. Perfect. So now we have a subset of the table displayed for us. So we have 5 models that have their F1 score greater or equals to 0.81. Okay, so we have 5 models here. So that's how we do it. Now let's proceed. We are now at the final stage where we generate the heat map. We are going to use Seaborn. So here we supply Seaborn with a data frame. And we also indicate this parameter here, R not equals true. Heat maps by default will generate plots with colors. So if you want to indicate the scores or the values themselves in that particular plot, then in Seaborn we use this parameter here. We set it to true. We also use the CMap here to specify a color scheme that we want. Here I'm using the blue color scheme. And so I'll run this command. This line here will label the x-axis and this will label the y-axis. So let's run this command. Perfect. So now we have our heat map generated for us. So we have our classifiers, we have our metrics here. Okay. And here we have the color scheme and we also have some interpretations here. So if, let's say here, there was no value here, then using this information here, using the values here, you'll be able to map out, okay, and then interpret, okay, and then look at where the scores are high and where the scores are low. So that is how we use Seaborn to generate heat maps. So let's proceed. So here I can right click and then just save this image. Let me just say heat map. I'll save it on my PC. Perfect. I can also save the data frame. So I can say results dot to CSV. And then I will say scores dot CSV. And then I'll run this command. Perfect. So I have everything. So I'll just go to my PC. I'll show you that one. So I have them here. So there's the heat map. This is a file that has the scores. Let me open this one first. Okay, so I have my models here, and I also have the scores here. So it now becomes easy. Okay, so that's it. Now let's go and interpret the heat map. Okay, so now we have the heat map that we generated. And let me also say that with heat maps, you can generate them without the values of scores. So you can have them this way. And so it depends on what you want and what message you want to get across. You can decide to use this or that. Now with heat maps, there's a color scheme that will help you to interpret your results and also identify patterns. So that is one good thing about heat maps. So the color scheme here helps you to know the scores or the values for each particular cell here. Now I will switch to the heat map without the scores. This will help us to easily identify and visualize the patterns here. Now, this particular heat map is using a blue color scheme. And so we have light blue and we also have dark blue. So here, light blue indicates a low score, and then a darker blue, or those with dark blue colors are indicating high scores. So let's use that to interpret the results. And so using that, we can see that in general, all the classifiers had low scores for these two metrics, Cohen kappa and then Matthews coefficient, because from the color scheme, you see that they are very light or somewhere between. So most of them were between this particular color range. So it indicates that with respect to these metrics, most of the classifiers had low scores. And so if you were to use just these metrics, these two metrics, I will say that the classifiers did not do well in general. But we have other metrics here. So you just use all the metrics to collectively evaluate, the classifiers that we have. So let's proceed. So you can see that with the classifiers, if you look at these four metrics, accuracy, precision, recall, and the F1 score, they all had fairly high scores. They all have high scores here. So they were all within this particular range. So if you are to look at the models that perform very well, what I see is XGBoost, SVM, and then random forest. Because if you look at the color scheme here, and then comparing with the others, these are the ones with high scores, because a darker blue or dark blue indicates high score. And so these three, XGBoost, SVM, and the random forest, are the ones that perform very well. But because the scores are not here, it becomes very difficult to pinpoint the exact classifier which performs very well. Here, these three appear to all have high scores. So you can use the scores to try and then go deeper. So let's switch to the other heat map. Perfect. So now let's compare. We are going to compare just the three top classifiers. So if you look at XGBoost, 0.82, 0.82, 0.81, 0.81, we have 0.72, 0.72. SVM, we have 0.82 and then 0.72. Random forest, 0.82, 0.82, 0.82, and then 0.72. So comparatively, the top classifiers are random forest and then SVM, because they all have the same scores. The scores here are the same. And when we come to XGBoost, there is a slight drop. So 0.82, 0.81. And so these two are the top performing classifiers. That is what we have from this particular heat map here. If you look at all the metrics here. And then the classifier that performed the least, or that had low scores, the worst performing classifier was naive Bayes. That is what we have here. So using the heat map, it becomes easy to do this visualization and also compare the performance of the classifier. So that is one good thing about using heat maps. Now, even though naive Bayes is not performing well here, it does not mean that always naive Bayes will perform poorly. The performance of classifiers depends on a lot of factors. It can be the data, it can be the number of samples. I mean, there are a lot of things to consider. So even though in this particular experiment, naive Bayes is not performed well, it's not an indication that naive Bayes is a bad classifier. No. These classifiers have their strengths and weaknesses, and that is why it's important to always use several classifiers, and you can look at the one which gives you the best performance and then use that for your other activities. So that is how we use these heat maps to visualize and compare the performance of classifiers. So that's it. So all too soon, we've come to the end of this tutorial, and I believe it has been helpful. Let me also get your comments and then We can have some discussion going. I'll be very happy if you can also suggest how I can improve the tutorials that I'm making. If you also want to support the channel, there are links in the description box you can use to buy me a coffee. So just do that and keep the channel growing. So that'll be all for this tutorial. Thanks for watching, and I will see you in the next session. Goodbye.